Alright, in this video we're going to investigate linear motion, and within that acceleration, deceleration and velocity, displacement and distance. The key knowledge is obviously listed there, and the key skills will appear throughout all of this video series as they relate specifically to each one of the biomechanical principles. Just before we get started, I just want to highlight something in the PE notebook. So if you open up your Unit 1 PE notebook, on the right hand side, so actually at the top we've got the biomechanical movement principles tab, and we're looking at the straight line linear motion page, and you've got some resources there. And if you scroll down, there are some structured questions which we'll get to a little bit later on. And if you want to take any notes while this presentation is going on, just insert your notes into this spot right here where it says take notes here. So we'll get started. So when we're talking about biomechanics, we've got motion is one of the key elements of that. And within motion, we've got linear motion, so movement in a straight line, and then we've got angular motion, so that's motion about an axis. Some of the key concepts, as I've already mentioned, are distance and displacement, speed and velocity, and acceleration. As we've talked about already, biomechanics is a study of living things from a mechanical perspective, and it's kind of like the physics behind human movement. In motion, we have general motion, which can be a combination of linear and angular motion, and linear motion can be subdivided into rectilinear and curvilinear motion. So linear motion can be defined as all body parts moving at the same speed and in the same direction. This can be in a straight line, or it can be in a curved line. So even though this is curved, it's still considered to be linear motion, and that's what we call curvilinear. And when things move in a direct straight line, that is rectilinear motion. Angular motion occurs when movement occurs around a central point or axis, so it needs something to rotate about. So the horizontal bars, parallel bars in gymnastics are a perfect example of a person moving in around an axis, a point of rotation. The key elements of linear motion are distance and displacement. Now they're quite similar, however there is one key difference. Distance is the path travelled from start to finish, so pretend a netball player moves along this sort of path, we would measure their distance travelled. Displacement is defined as change in position, so that is as the crow flies from the start position to the finish position. So in this case, distance might be say 6-7 meters, but the displacement might only be 3 or 4 meters because they've gone in a straight line. In an athletics track, if we talk about the distance around the athletics track, it is 400 meters. But if we're looking at displacement, if someone runs a 400 meter race and they start, they're going to run all the way around, and then they're going to get back to the start back to the finish line, which is where they started, which means that their displacement is actually 0 meters because the runner starts and finishes at the same point. The next element to that is to look at how fast things move, and it's useful to measure how fast things move. Speed and velocity are the two measures of how fast something is, and the key difference between the two is that speed is distance divided by time, and velocity is displacement divided by time. Now velocity is important because it tells us what direction the movement is in. So if we go back to the previous slide, the velocity would use this blue line to measure the displacement and then divide that by the time that it took to get to that position, whereas the distance would, the speed would be the distance divided by that time. The good thing about using velocity is it tells us exactly the direction that that person is heading. For example, again in the netball, that person might have been travelling at 5 meters per second in a southeasterly direction. Acceleration is the final key term in linear motion, and that is defined as the change in velocity over a period of time. If acceleration is positive if the object is speeding up, and it's considered to be negative when slowing down. You might hear the term deceleration. It's actually negative acceleration. If something has zero acceleration, it means that its velocity is constant. Okay, it could mean that the object is not moving at all, or it might mean that the velocity is a very consistent pace. And acceleration is measured in meters per second squared, because the formula for acceleration is change in velocity divided by time. So what we're going to do now is we're going to go through a few worked examples. Then you're going to do some activities to calculate velocity and acceleration. So the first example here, we've got a swimmer who swims the 50 meters in 21 seconds, and we need to calculate her velocity in meters per second for the race, nearest to 2 decimal places. So the first step, easiest step, is to write down the formula that we need, and we're looking at velocity. So the formula for velocity is displacement divided by time. Now in this case our displacement is 50 meters and our time is 21 seconds. So we just plug it in, 50 divided by 21, and in the calculator that will give us a value of 2.38 meters per second, and that's the units we use for velocity. You can see there that I've written in the nearest to 2 decimal places, so it's important to put that part into the formula as well. So we can say that that swimmer's velocity over the course of that race was 2.38 meters per second. So for every second she was travelling 2.38 meters. Sorry, not sure what happened there. We're on to the next slide. The same swimmer later on in the meet swims 100 meters in 48 seconds flat. We need to calculate her velocity in meters per second for the race, nearest to 2 decimal places. So again, we are trying to calculate velocity, so we use the formula velocity equals displacement divided by time. However, this time, because it's 100 meters and we're in a 50 meter pool, the swimmer will swim up and they will swim back and they will arrive back at exactly where they started, which means that the displacement is 0. So for velocity it's 0 divided by 48 seconds, and in this case that means that 0 divided by anything is going to be 0. So her velocity for that race is 0 meters per second. And the reason that is because the velocity describes the direction of movement. It's not just about how fast that person has gone. If we wanted to work out how fast she had gone, we would have used speed in this case. But velocity is useful because we want to find out how fast someone has moved, but also have the direction involved. Okay, a slightly more challenging one. We've got a marathon runner and they've run from Frankston to Melbourne, and it took them 2 hours and 50 minutes. What we need to do is calculate his velocity in meters per second for the race, assuming that it is a straight line between Frankston and Melbourne. And we need to calculate that to 2 decimal places. So again, we get out our formula for velocity, which is velocity equals displacement divided by time. And in this case, it's 42.2 kilometers is the displacement, and the time is 2 hours and 50 minutes. Now, it's asking us to calculate the velocity in meters per second. So what we're going to do now is convert these numbers into meters and seconds. So 42.2 kilometers is 42,200 meters, and 2 hours and 50 minutes works out to be 10,200 seconds. So then again we get the calculator out and we can calculate that this runner has run 4.2 4.14 meters per second for the duration of that marathon. So for every second that occurred, that runner was running 4.14 meters on average. Alright, the next one is going to look at how we can calculate acceleration. So a potential AFL player completes a 20 meter sprint, which is a pretty common test in the AFL, in 3 seconds flat. So what we need here is the initial velocity and the final velocity, which we've got as being 0 and 9 meters per second respectively. As a recruiter, you want to know what his acceleration is to determine if you want to draft him. So we're going to calculate his average acceleration in this test. So the formula for acceleration is acceleration equals change in velocity divided by time. And to calculate change in velocity, we need to subtract the initial velocity from the final velocity. And in this case, I've actually made a mistake there, sorry I didn't change it. The final velocity is 9 meters per second, so 9 minus 0 is obviously going to be 9, and this should be read here 9 meters per second, so just ignore that. Therefore, the acceleration is 9 change in velocity meters per second divided by 3 seconds. Therefore, the acceleration is 3 meters per second squared. So for the 3 seconds of that test, that person was accelerating. Each second they were accelerating by a further 3 meters per second on average. So that is how we calculate acceleration. Alright, we've got some worked examples, some structured questions. So in your notebook, again in the biomechanical movement principles and the straight line linear motion page, there is an activity there to calculate the 100 meter sprint times of Usain Bolt, the velocity and also the acceleration. So go to page 70 of your textbook and answer questions A to G.